Distance with integrals, as related to position. A particle moves along the x-axis with a velocity given by this thing. Oh, that's ugly. For the time t is greater than 0, if the particle is at position x equals pi at time t equals 0, let's draw a little image for that. Boom. T equals 0, pi is there, or the dot is on pi. Which of the following gives the position of the particle at time t equals 4? So at t equals 4, that's what we want to know. We don't know where on this number line is the particle at t equals 4. So really quickly, let's talk about a few things. Okay, if you guys were to plug 4 into the velocity function, you're going to get a velocity number. That's speed. It's not going to give you the position or give you anything of value for this problem. So we don't want him. If we instead take the antiderivative of velocity, we get something known as the distance number, okay, or the position function. And so this is really good news. So we can take the velocity number or the velocity function, take the antiderivative of it, and get some kind of a distance number. Now I have to do a quick review of the difference between displacement and total distance. So here we go. First of all, if you take the antiderivative of velocity just straight like this between 2 points, A and B, you get something known as displacement. What the heck is displacement? Displacement is this. This new point, this new position is 3 spaces away from pi. Okay, so in order to find that new position, you would go pi plus 3. Boom, you got your new position. Or displacement would give you -5. And so this new position would be pi minus 5. That would be the position. Okay, well, what is total distance? Total distance does something actually a little different, because what you don't see with displacement is that maybe this particle went 2 to the left, and then it went 5 to the right, and then finally it went 8 to the left, and then finally you got your displacement at -5. It's -5 spaces away from pi. It doesn't take into account, like, you don't know what all those numbers are if you just do the displacement thing. So that's when this absolute value thing comes into play. This is known as total distance. If you take the absolute value of the integrand inside of the integral, you will get total distance. So while displacement will take the -2, the 5, and the -8, add them together and give you -5. And you don't know what the -2, 5, and -8 are. You just know -5. Total distance will take all those negative distance numbers and make them positive, giving you 15. So the particle in our example actually traveled 15, not -5. But actually, which number do we care about in this situation? We just want to know the position of our particle. So how do we find position? This is when we care about pi right now. Okay, I kind of already mentioned it. If we want to know where pi was or where our new position is, we just have to take pi and subtract 5 from it, right? The displacement. Okay, so in order to find the position, the new position, first we have to know the known position or the initial position. And so that's what we're going to start with. We're going to start with pi, and then we're going to add the displacement. In our case, it was -5. Okay, but we don't know if our displacement is -5, so let's just take the pi and add the displacement formula, which is the integral of velocity from A to B. In our case, it's from 0 to 4. Okay, so I think that's it. That gives us our answer. Okay, this is our known position. This is our displacement. And that gives us our new position. Booyah. That's your answer.